All right, here we go. This is the 17,001th time that I've recorded this video. I'm going to teach you how to take the derivative. Specifically, we're just going to learn how to take the derivative of a polynomial. And I'll teach you a little bit about what a derivative is. And then the rest of it, the rest of derivative stuff, that's why you are taking calculus right now. I'm going to teach you a shortcut here. You are not allowed to use it in your math class until your math teacher teaches it to you. If you took calculus last year, because you're in like super honors math, then you probably don't need to watch this because this will be super easy for you. But still do the homework assignment, and it'll take you like a minute. Okay? You can probably do all three of them, assuming there are still three of them at the time that you're doing this assignment. Okay, so here we go. Derivative. What's a derivative? All right, so the derivative is a thing you do to a function. So if you've got a function, f of x, okay? Got a function, f of x. The derivative of that function tells you how quickly the value of your function, how quickly the value of f of x goes up or down on your vertical axis per unit on your horizontal axis. All right? It tells you how much it goes up or down per unit, how much f of x goes up or down per unit on the x-axis. Basically, it tells you the slope of the function at a point. And in physics, these slopes have meaning. Okay, and so that's why we need to learn about this. All right, so let's talk notation. So suppose we wanted to find the derivative of f of x, right? Okay, well that's a lot to write out. So maybe you don't want to write those words out every single time, right? So in your math class, you'll probably learn a couple different types of notation. When I took calculus a zillion years ago, the first notation I learned for the derivative was this. So if you wanted to take, suppose you had f of x, and you wanted the derivative of it, you would write it as f prime of x. You put a little apostrophe mark there next to the f, and that means, hey, I'm the derivative. All right, so there's f of x, and there's the derivative of f of x, okay? And that's often read f prime of x or the derivative of f of x. All right, so slightly more technical notation, sometimes you'll write the derivative this way, and this is the way that we will do it in physics. We're going to write it as the derivative of f with respect to x, okay? So calculus is all about like small changes, all right? And so in math class, or chemistry, or science, whatever, we use the Greek letter delta to represent change in. Okay? But as your change gets smaller and smaller in math, we use the letter d instead of the Greek letter delta. So this is kind of like change in f of x divided by change in x, which you right now are thinking, wait a minute, that's kind of like change in y over change in x, which is the slope, which is what the derivative does. It tells you the slope of a function at a point. Okay? So another way to write the derivative of f of x is to write this, df over dx. Sometimes that is written the derivative of x, or the derivative with respect to x of f of x. Okay? Or even sometimes just. Now, why don't math people choose just one notation and stick with it? I don't know, because they're trying to make your life harder. So far, everything here in red means the same thing, just different ways of writing it. All right? And then finally, sometimes people will write it out in sentence form. And so if you want to be really wordy about it, you can say, instead of saying the derivative of f of x, you can say a function which gives you the slope of a line tangent to f of x at, I'll actually write out the word at x. Okay, that is what the derivative does. It gives you the slope of a line tangent to f of x at x. All right? So let's do some examples. And again, this is all just about how to, all right? So I think probably the easiest way to do this, I'm going to use some Desmos. You ready? Oh, why is this guy still here? Go away. All right, so this right here, I don't know if you guys are familiar with Desmos, but this is the equation f of x equals 4. Okay? What is the derivative of this? Well, at this point, basically we're just finding the slope. okay? And so, here's your f of x-axis. Here's your x-axis. What's the slope of this thing? Oh, well, the slope is 0. And everywhere on this, the slope is 0. No matter where you go, slope is 0, slope is 0, slope is 0, slope is 0, right? So it would be accurate to write f prime of x is 0. Or you could write the derivative of f with respect to x is 0. Is 0. Or you could write the derivative with respect to x of 4 is 0. Okay? So this function, because it is just a horizontal line, has a slope of 0, and as a result, the derivative is constant. Okay? Not too crazy. All right, let's do this one. This is the equation f of x equals 4x. That's sort of like, so if you think y equals mx plus b, this is like plus 0, so our slope is 4. And in fact, it is, right? Because if I run 1, I rise 4. There you go. The slope is 4. Therefore, I can say f prime of x is 4. F prime of x is 4. Or I can say the derivative of f with respect to x is 4. Because once again, the slope is constant. The slope is not changing. So no big deal. All right? So why do they have all this fancy terminology for derivatives? I'll tell you. That's why we're here. Check it out. Suppose I give you some crazy function like this. All right? This function is so crazy, I'm going to fatten up my red pen. Here we go. Here's what this function is. F of x. I said, why did it not get fatter? It didn't get fatter. All right, we're just going to have to deal with it. So this function is x cubed minus 15x plus 48x. It's a cubic polynomial, all right? And I entered it in over here. I put xxx because I was too lazy to type in x cubed. All right, so you'll notice the slope of this thing is always changing, right? Like right here, at x equals 0, it's got a really big slope. Look how steep it is. I hope my camera's oriented the same way, but is that right? It's going up and to the right, very steep, right? Then when you get to here, it's not quite as steep, and then up here, it kind of levels out, right? So we've got a big slope, smaller slope. Up at the top, we will learn up here the slope is 0. Over here, the slope is negative, and then it's really big negative, right? And then it's still negative, right? So the slope is always changing. What are you talking about, Mr. Hacker? How are you finding the slope of a curve? That doesn't make sense, right? Well, you're right, it kind of doesn't. What I'm actually doing is I'm talking about the slope of the tangent line. So perhaps you remember from geometry that if you've got a circle and you want to find a tangent line, so there's, I don't remember this, I should have looked it up beforehand, but there's like chords and bisectors and I don't know. Anyway, a tangent line is a line that, so suppose I pick a point. There's a point on my circle. A tangent line is a point that crosses the circle or touches the circle at exactly one point. And there is only one such line, and it looks like this. And if you rotate that line in any way, shape, or form, it's going to hit the circle at more than one point. Okay? So that's what a tangent line is. It hits the shape at exactly one point. So if we go back to our graph over here, let's draw in our tangent lines. So at this point right here, our tangent line is going to look something like this. At the top, it turns out the only way you can do it is if it's horizontal. Over here, it's going to be something like that. All right? Well, let's be more specific about it. Let's look at it. I used my Desmos to plot it. All right, so here we go. We are going to open up. I need to click this guy. Nope. Oh, I need to. Boop, boop. Here we go. There we go. Like that guy. Boop. All right. Doot, doot, doot. Boop. No, boop. Like that guy. There we go. Oh, yeah. So look. So you can see that the point here is labeled. So when, I'll just move it. Oh, look at that. All right. So see that this little, oh, that's not what I wanted to do. There's this little circly dude here, right? I said there's a little circly, oh my goodness. You know what would be cool is if I knew how to use my smartboard. There we go. So there's that little point there that's kind of like highlighted, right? And you can see this dotted line here, that's our tangent line. And right now it's really steep, right? And so now if I go back to this guy, and I move it, you can see that the slope of that tangent line keeps changing, right? And just like I said, at the top, that tangent line has a slope of 0, right? Okay, and then it becomes negative, the slope is negative, it's getting more negative, more negative, more negative, more negative, right? All right, and if you go farther over, oh, down there at the bottom, again, the slope is 0, right? It has to be because it's going from a negative slope to a positive slope. So there at the bottom, the slope has to be 0, all right? That's a really important thing, these points here are called local, this is a local maximum. That's what that's called. We should write that down, that's important. All right, here we go. This is called a local maximum. It's not the maximum for the whole function, but like in this little neighborhood here, that's the maximum, right? And it occurs at x equals 2. And then you can probably guess this guy down here, yeah, look at you. Look at the brains on you, local minimum. All right, and that occurs at x equals 8, okay? All right, so anyway, my point here is the slope of this tangent line keeps changing, doesn't it? If only there was a way to write an expression for the slope of that tangent line as a function of x, right? Like there's got to be a function that tells me, you give me an input, an x value, and I'll tell you what the slope of that tangent line is at that point. That's what the derivative does, okay? That's what the derivative does. So how do you take a derivative? How do we find out the slope of this tangent line at any point? I'll show you. Let me see, I forget what I put here. I edited this. All right, so how to take the derivative of a polynomial. All right, so there's a bunch to this. Part of the reason this video took so long so many times is because I tried to break it up into too many things. All we need to know is how to take the derivative of a polynomial. So let's pick a random polynomial. Here you go. I'm just going to make something up. So here we go. F of x is 8x to the 5th minus 3x to the 4th plus, I don't know, let's do 6x cubed minus 7x squared plus 3x minus 4. All right. So here's what you're going to do. To take the derivative of a polynomial, what you're going to do is you go one term at a time. I'll do the first couple, and then I'll let you do a couple on your own. It's going to be awesome. So you go one term at a time. So what you're going to do is, so there's a coefficient and a power. What you're going to do is you're going to multiply the coefficient by the power. So I'm going to go 8 times 5, that gives me 40, times x to the, and then you just decrease your power by 1, right? The original one, the power is 4. I'm sorry, the power is 5. 5 minus 1 gives you 4. There you go. Then whatever the next operator is, you bring that down. So I got a minus sign. I'm going to bring down my minus sign and then do the next term. So let's see, we got 3x to the 4th. So 4 times 3 is 12 times x to the 4 minus 1 is 3. Bring down the operator. Let's see, 3 times 6 is 18. X to the, it was originally 3, so it becomes 2. We'll just keep doing them. I'll give you one to try in your own in a minute here. All right, bring down, let's see, we got a minus sign. Let's see, 2 times 7 is 14. X squared becomes x to the 1st, which I'm just going to write as x. Ooh, what about this? 3x. Well, if it was just f of x equals 3x, what would your slope be? Your slope would just be 3, right? How does that work? Well, this is really 3x to the 1st power. So 1 times 3, oops, I forgot my plus sign. 1 times 3 is 3, and then x to the 1, but I got to decrease the power by 1. That gives me 0. X to the 0. X to the 0. What is x to the 0? That's 1. So 3 times x to the 0 is the same as 3 times 1, which is 3. All right? Minus, well, the derivative of 4 is 0, isn't it? Or if you want to do it this way, 4 is the same as 4 times 1, which is the same as 4 times x to the 0. So 0 times 4 is going to give you 0 times whatever is going to be 0. So the derivative of a constant is 0. All right? Why don't you try one? We'll give you one that's a little bit shorter. Oh, wait. So what is this? What did we just find here? What we just found is f prime of x, or equivalently, the derivative of f with respect to x. Cool? All right, let me give you one to try. Boom! Oh, it worked that time. All right, here we go. So let's do this. How about g of x? So g of x is, I don't know, let's do negative 6x to the 7th minus 3x to the 4th plus 2x minus 8. See if you can find the derivative of that. So to be clear, what are we looking for? We're looking for g prime of x, also known as the derivative of g with respect to x. All right, pause the video right now. Take the derivative. I don't actually have to wait. I'm going to just assume that you did that. So welcome back. There we go, derivative. So here we go. Derivative of this, let's see, 7 times negative 6 is negative 42 times x to the 6th. Minus 4 times 3 is 12x cubed plus 2, and then the derivative of 8 is 0. Cool? So there you go. All right, I have a little note down here. Look at this, I wrote myself a note. What about negative exponents? Let's do one more. It's the same rule. So nothing different, even if the exponents are negative. But it comes up every once in a while. Let's do h of x. H of x is going to be 12x squared minus 4x plus 5 minus 5. We just used 5. Let's do 3 over x plus 6 over x squared. So the first thing you want to do, I hate fractions. You should too. Get on the fraction-hating bandwagon. Let's rewrite this. So this is the same as 12x squared minus 4x plus 5 minus 3x to the negative 1 plus 6x to the negative 2. All right, so there we go. There's h of x. Let's find our derivative. Oh, I'm using this again. It's super clicky. I forgot I was supposed to not be doing that. All right, so here we go. H prime of x, or dh dx, is, well, let's see. It's going to give me 24x to the first minus 4. Oh, I guess we can color code, right? Minus 4. Right, because this is 4x to the first, 1 times 4, and then x to the 0 is 1. All right, let's see. This guy just goes away. The derivative of 5 is 0. The derivative of a constant number is 0. Derivative of a constant is 0. Derivative of a constant is 0. It's on the radio. I heard that on my way to work this morning. All right, oh, no, and he's yellow. All right, so now we got this one. All right, let's see. Negative 1 times negative 3 is plus 3x to the, be careful, negative 1 minus 1, right? Remember, your rule is you decrease the power by 1, right? So negative 1 minus 1 is negative 2. And then finally, let's see, well, I don't know, plus, I guess, let's see. 6, or negative 2 times 6 is negative 12. That was why I was hesitating there. We're going to get a negative x. And then negative 2 minus 1 is negative 3. There you go. That's how you take a derivative. Cool. Of a polynomial. There's a bunch of other stuff you can take derivatives of. We'll do that later. All right, so what do we got to do? All right, so let's go back to this function. So we've got this, this function here, t cubed minus 15t squared plus 48t. Sorry, there was an example behind this. You guys don't really care. So I gave this function meaning, right? So here, C is meant to represent the profits of company T, or of company C. So we've got a company called Company C. They need a new marketing person. And then this gives you their profits after T hours of being open, okay? And it says at what rate are the profits changing? How much do the profits go up or down per hour at 4 hours? And then at what time should we shut the doors? All right, so this function here, you probably didn't realize, is the same as this function. I just changed my t's to x's. All right, so, and, oh, yeah, well, so there's that guy, right? So that's t cubed instead of x cubed minus 15t squared plus 48t. All right, so this is what this function looks like. So after 4 hours, their profits are decreasing. And it looks like if they're only open for 10 hours, because that's how long most businesses are open, I just made that up and you're just gonna have to deal with it. If they're open for 10 hours, when should they close their door? Right here, after 2 hours. But I know that because I'm looking at the graph. What if we didn't have the graph? What if we didn't have the graph? Well, let's go back to our example over here. All right, so we've got this function. I feel like I need some more space to work with. All right, so here we go. So our original function, c of t, is t cubed minus 15t squared plus 48t. And this question says, at what rate are the profits changing? At what rate are the profits going up or down per unit time? Oh, derivative, okay? Anytime you hear the word rate, you should think, oh, it's probably a derivative. All right, so let's find c prime of, let's find c prime of t, also known as the derivative of c with respect to t. So I'm just going to use the polynomial rule I just taught you. Oh, there's no coefficient here, right? There's really a little invisible 1 in front of that. That's 1 times t cubed, right? All right, so we're going to get 3t squared minus, let's see, this is going to give me, what, 30t? And then plus 48, right? Okay, cool. So if I want to find out at what rate the profits are changing after 4 hours, I just got to plug it in. So c prime after 4 hours, the derivative of c after 4 hours is, we'll just plug in 4. So you get 3 times 4 squared minus 30 times 4 plus 48. And if I remember right, this gives you negative 24. Let's see, 16. So 96 minus 120 is, yeah, negative 24. And then the units are going to be, what, thousands of dollars per hour, whatever. The slope is negative 24, whatever our units are. So what that means then is we go back to our graph over here. After 4 hours, ooh, try again. After 4 hours, boop, 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 boop. This line right here has this line here. Oh, that one, the tracing right there, has a slope of 24. All right, well, let's see. Let's check it out. Right here, it's not going to work. Yeah. Okay, anyway, there you go. It certainly is negative. Oh, here's how we can do it. Just look. Let's see. So from, if I go a run of 1, then I should go down about 24. And it looks like, what are these? These boxes are 10, 20, 30. Yeah, each box is 10. So I believe that that's 24. Run is 1. Rise is negative 24. Hooray, there's our slope. There's our derivative, right? Okay, so there we go. Now, so that's how you find a derivative. And we just found the rate of change after 4 hours. All right, now suppose we wanted to figure out when this happens. All right? Well, again, the important thing is at this max and at this min, our derivative is 0, right? The slope is 0. So to find our local max and our local min, we're going to take the derivative, which we've already done, and set it equal to 0. Let's do this. So let me go back to this. Here's our original derivative. C prime, oops, I'm using that pen again, of t is 3t squared minus 30t plus 48. But I want to set it equal to 0. Now, you've got a calculator. You can solve this using your calculator. That is totally the easy way to do it. If you don't know how to do that, you need to figure it out. You can ask me on the first day of school, and I'll say, you know what, I don't know, I'm bad at graphing calculators, but there's someone in this room who does. Or your math teacher will teach you, whatever. I'm going to go old school. I'm going to factor this mess. Oh, look, everything's divisible by 3. Oh, now I've just got a regular old quadratic, right? Let's see. What adds up to 10 and multiplies to give 16? Oh, 2 and 8. So this is 3 times t minus 2 times t minus 8, right? If you FOIL that out, it gives you the same thing. Oh, and since it equals 0, that means either t is 2 or t is 8. So one of those has to be our max. One of them has to be our minimum. All right? To figure out whether each of these is a max or a min, you'll learn that in math class. I'm going to not worry about it. But now I know that each of these points are either maximums or minimums. So now suppose I wanted to know, what the values were. Like suppose I wanted to know what is the maximum profit. Well, then what I'd have to do is I'd have to put this back into my original function. Okay, like let's figure out what our profits are after 2 hours. So I'd go C of 2 is 2 cubed minus 15 times 2 squared plus 48 times 2, and figure out what that gives you. So what are we going to get? 8, 60, I don't know, whatever. This gives you a number that I'm being stupid. I'm sorry. I totally had this written down like the 8th time I did this video. So 8 minus 60 plus 96. There we go. 44. Okay, so that's our maximum, is 44. Does that agree? Let's see. After 2 hours, boop. Oh yeah, 44. There you go. Cool. All right. So, what have we learned? Take a derivative, use the little power thing that I showed you. You can find the maximum or the minimum by setting the derivative equal to 0. And that derivative tells you the rate of change. It tells you at a given instant how quickly your vertical value is changing with respect to your horizontal. Okay, with respect to means for each unit. Okay. All right, that's that. Ugh, man, can't keep these things under half an hour. Sorry, you guys. I'm working on it.